This is the video solution to problem 12 from the review exercises. We're going to consider a discrete random variable x with a moment generating function given by m of t equals 0.6 plus 0.3 times e to the 2t plus 0.1 times e to the 2.5t. We're going to start by finding the probability mass function of x. Now the thing to remember is that m of t is the expected value of e to the tx. So what we get when we look at this, we've got sort of 0.6 here, and we can think of that as being times e to the 0t, because that would be times 1, plus 0.3 times e to the 2t, plus 0.1 times e to the 2.5t. So think about like these coefficients up here are the possible values that x can take. And the probabilities associated with them, like e to the 0t times the probability that x takes on the value 0. So this is going to be our sort of f of x. It's going to be 0.6. The coefficient 2 up here in the exponent gives us 0.3 as our f of 2. And with the coefficient of 2.5 in the exponent, we have this probability associated with it down here, 0.1. So there is our probability mass function. Now, part B asks us to find the mean of x. And so I can use the moment generating function to do this, or I could use the probability mass function. But if I'm using the moment generating function, I'm going to take the first derivative and evaluate it at 0. So that's going to give me 0 times this whole piece, so that goes away. So I get 2 times 0.3 times e to the 2t. But I'm evaluating that at, well, we'll do m prime of t first, then I'll evaluate it at 0. Plus 2.5 times 0.1, not 0.01, 0.1 times e to the 2.5t. So when I evaluate this at 0, I get 2 times 0.3 plus 2.5 times 0.1, which gives me 0.85, and that is my mean. Part C asks me to find the variance of x. Now to find the variance of x, I'm going to use the fact that the variance is equal to the second derivative of the moment generating function, evaluated at 0, minus the mean squared. And this is because this moment generating function second derivative, this is giving me the expected value of x squared when I evaluate this. So let's start with the second derivative of the moment generating function, m double prime of t is going to be 2 times 2 times 0.3 times e to the 2t plus 2.5 times 2.5 times 0.1 e to the 2.5t. When I evaluate that at 0, I get 4 times 0.3 plus 2.5 squared times 0.1. It gives me 1.825. And so my variance is going to be 1.825 minus 0.85 squared, and that is going to give me 1.1025. So there is my variance of x. Part D asks me to find the expected value of 4x plus 1. Now I can use the fact, remember when I have sort of just a little aside, the expected value of ax plus b is equal to a times the expected value of x plus b. So in this case, what that means is that this is equal to 4 times the expected value of x plus 1. The expected value of x is 0.85, so I'm taking 4 times 0.85 plus 1, which is going to give me an expected value of 4.4. And part E asks me to find the variance of 4x plus 1. If you remember, when I take the variance of ax plus b, that is equal to a squared times the variance of x. So this is going to be 4 squared times the variance of x. So that's going to be 16 times 1.1025, which gives me 17.64 is my variance for 4x plus 1. And that is the end of question 12.